Here is Hess's Law Extra Practice Worksheet, question number 1. So how I like to solve Hess's Law is not the only way to solve Hess's Law, but I'm just walking through my thinking. So I like to look at what I'm trying to find, and then I just shuffle the pieces around so that they match those pieces. So I see here that I need 2 carbon dioxides. I scan my given reactions and I see 2 carbon dioxides here. They're in the reactants, or sorry, these guys are in the products, but I want them to be in the reactants. They're in the products, so that I'm going to have to reverse this reaction. When we reverse the reaction, we have to switch the sign. That negative becomes a positive. I have 2 I want to, so I don't need to scale this up or down. I like to rewrite my equations going the way that I want them to go. So I'm going to go ahead and rewrite this equation. Because it's easy for my brain to keep things organized if I see them like this. So now I've got my 2 CO2s, 2 CO2s, check. I need 1 water. I have 3 waters, I need 1. So I need to find a way to get rid of 2 of these guys. I'm going to take this reaction, I'm going to double it so that I have 2 H2Os, but I'm also going to reverse it so that I have 2 waters in the products, which will cancel out 2 of them in these reactions. So again, I'm going to flip and double, which means I have to double and flip my sign here. So again, rewriting this the way that I want it to go, I've got 2 H2s. 2 times a half is going to give us 1 oxygen. And then we're going to have 2 waters. Delta H is going to be twice negative 71.2 kilojoules. So now I can see that I have already canceled out 2 waters. If I take away 2 waters here, I take away 2 waters here, I only have 1 water left. I can also subtract 1 oxygen from both sides. 1 is the same as 2 halves. So 7 halves minus 2 halves is going to leave us with 5 halves, which means that I also have a match for my 5 halves oxygen here. And 1 water here. It's just this ethyne that I need to figure out a way to get into my system, get this guy out of my system. So C2H6, this ethane, I see it here. I want it to go away. I need it to get out of the products, so I'm going to keep it in the reactant. No, that's wrong. I want this guy. Sorry, I'm trying to get the ethyne. Ignore all those words. I want this guy in the reactants, but I can get this ethyne into my products. So I'm going to take C2H6 and I'm going to put it in the reactants. I'm going to flip this guy, which means that we have to change the sign of this guy. I don't need to scale it. I just need 1. I need 1. I need 1. So rewriting this guy, C2H6 is going to yield C2H2, 2H2. Delta H is going to be positive 94.5 kilojoules. So now I can go ahead and cancel out C2H6 on both sides, and what's super convenient, I can also get rid of those 2 H2s. So what we're left with, 2 CO2s and 1 water. That guy's gone, gone, gone. Over here, I have 5 halves of oxygen. Water's gone, hydrogen's gone, ethine is left. This is exactly my equation. So now all I have to do is add up these pieces. Negative 71.2 times 2 is negative 142.4 kilojoules. So positive 283, negative 142.4, positive 94.5. It's going to give us a grand total of positive to 35.1 kilojoules.